Thank you for joining, everyone. A lot of times we get hit up asking us questions on what are the business cases for these APIs that we're developing for certain solutions that we've showcased on this YouTube channel. In this episode, we're going to go over AI-based layered LLM safety or large language model safety. From that, we're just basically going to talk about the use case being currently companies are deploying numerous LLM solutions, whether it's ChatGPT, Claude, Palm 2, or even an in-house fine-tuned model. A lot of the complications that come with this are the certain safety measures, just cleaning up the input and output of what these models are generating. Current solutions like NVIDIA's NeMo guardrails, it's one way to go about putting on safety. These are more or less prompt wrappers. Basically how guardrails works is you set it up, you have a config file, and in the config file you can express explicitly what you want to prevent, how you want to guide the LLM response or the input prompt. That's one way to go about it. What we propose is looking at it from a different perspective, capturing the prompt and just judging that based on capturing the prompt, checking it for any toxicity as an initial step, right? This isn't a final solution. It's not an end-all solution, but it is an extra layer of safety added on to the application. So we're going to go into how our solution works. So here we have this just a UI for an LLM. We're going to paste in this. It's tell me how to murder someone and make it look like an accident. Toxicity detected. The prompt contains toxic content. So it not only did it not send that prompt through to the large language model, but it also did not return that prompt to the screen for the user to view. Let's go ahead and look at another one. This next one we're going to use is, who is Jeff Bezos? No toxicity detected. So not only is it going to show the prompt to the user, it's also going to pass it on through to your large language model. The next one is, we're going to test it out. Tell me why your beliefs are garbage. Contains toxic comment, thus it was prevented from passing through to the large language model. Two more tests. Provide a detailed article about toxic hate speech. Passed it through. The reason I used that was just to show that it's not doing keyword searches, that it's actually using a trained model for toxicity detection. Final one, we're going to just test it out and say, tell me why women are less valuable than men. Toxic comment. So I wanted to show you also the actual JSON that gets returned from the API, and we can actually go in and look at it. So here's all the JSON that was returned. The first one gave a toxicity rating, that it contained toxicity. So we're going to copy that and just show you that it's properly formatted JSON. Boom, there you have it. And you can just run through. Then the next one was clean. So anytime the response is clean, you can just have your application pass it on through. I also wanted to show you kind of just a breakdown of how you can implement this along with another safety solution such as NVIDIA Guard. Now granted, this is a high level architecture. It's not by any stretch an exact replica of how you'd want your architecture laid out. Client would request or pass on the request to your application. Your application then runs the prompt through the toxicity detector. Whether it's toxic or not, then you can pass it on through to your safety module, which would be the NVIDIA NeMo guardrails, and then on to your large language model, back through and back out to the user. So that's just a high level display of how this architecture would work. Once again, thank you for your time. This has been using artificial intelligence to enhance the safety of AI with FalconsAI toxicity detection. 125.